Hi, in this video I'm going to talk about planes and vector equations of planes. Now a plane is a flat two-dimensional surface and the first thing we're going to talk about is the normal vector to a plane. Now the normal vector, usually denoted as a vector n, is a vector that is perpendicular to the plane. So we can calculate that if A and B are any two vectors that lie on our plane, then the cross product between A and B gives us a vector which is perpendicular to both A and B, and because A and B lie on our plane, then A cross B must be perpendicular to any vector which lies on our plane. So the way to calculate the normal vector is simply calculate the cross product of A and B, and if you're unsure how to do that, I have done a previous video on the cross product. Now the normal vector is very useful for defining a plane. We define a plane using the point normal form. So the point normal form of a plane in R3, which passes through the point with the position vector P. So here we have in this diagram P is a point on our plane and a normal vector to the plane N. And if R is another point on our plane, well, by the geometric definition of a dot product, the dot product between two perpendicular vectors is 0. Now the vector points from P to R, which is equal to R minus P. If I dot product that with the vector N, which, because it's a normal vector, must be perpendicular to R minus P, then this should be equal to 0. So R, we can say this is any vector, any position vector with the elements X, Y and Z. And this is known as a point normal form of a plane. Okay, so let's have a look at an example. So here we have a plane which passes through these three position vectors, so the three points with these position vectors. So the first thing we need to do is calculate the normal vector to the plane. So I need any two vectors on the plane. So essentially I need the difference between any two pairs of these points. Now it doesn't matter which ones you choose. Okay, all you need is a vector that lies on the plane. Okay, so I've chosen P1 minus P2, cross product with P3 minus P2. Now, depending on which way round you do the subtraction, that will depend on which direction you want the normal vector pointing in. Now, for some applications, for example, computer graphics, we want the normal vector to point in a specific direction, but for now, I'm just going to take any arbitrary normal vector. Okay, so P1 minus P2 gives us this vector, and P3 minus P2 gives us this second vector. Now if I calculate the cross product, we have the vector 3, 1, negative 2. So that's our normal vector. Now using the point normal formula, and I could use P to be any of these 3 points, P1, P2 or P3, I'll get the same equation at the end. So I've chosen P1. Okay, so the point normal formula is the normal vector dot product with the vector R, which is an arbitrary point, minus P1. Now, I could have chosen P2 or P3 here, but I just chosen P1. Okay, so we've already calculated the normal vector. Our R, or the elements of R, is the X, Y, and Z coordinates. P1 is 1, 2, 3. And I can calculate this cross product, giving me 3x minus 1. So 3 multiplied by x minus 1, plus 1 multiplied by y minus 2, and negative 2 multiplied by z minus 3. And if I expand out the brackets and simplify, I get this equation here. So this equation is satisfied for any point on our plane. So any point with the coordinates x, y and z should satisfy this equation. So let's test it with P2. So P2 had the position vector 2, negative 1 and 3. So if I substitute 2, negative 1 and 3 in place of x, y and z, we see we have 0. So that confirms that P2 lies on our plane. And also do the same for P3, which had x equals 1, y equals 0 and z equals 2. And you can see that's also satisfied. So any point on that plane satisfies this equation here.